This is Chris from RoboSprout, and I'd just like to do a quick run through on how I tune my solder profiles for reflow in the ovens. Now, to do this method, you're going to need a couple of things. First, you're going to need a thermocouple of some sort. My oven has a plug-in directly for this normal thermocouple plug-in, and I can read it off of the monitor there, but not every oven does. So this is something I've used before. It's just a Max 31855 board. It takes a thermocouple and you can put it to a Raspberry Pi or an Arduino. And then you can actually do data logging where you can chart all of your plots to a graph, like you pull a measurement every couple of seconds. I found that's not super necessary, but it does end up being helpful. You'll understand a bit more when I get into it later. Aside from a bare PCB to start, some people advise using, preloaded PCBs. That's, more advanced stuff, but this is just the very basic, get your profile down stuff. You're going to need the thermocouple, a bare PCB, some Kapton tape, and then you're going to need, most importantly, the data sheet for the solder you're using. Now, this is available. You just look up the part number of whatever solder you use. Now, if you're getting some generic, came in a Ziploc baggie out of China stuff that you don't know what it is, that's, a bit of more of a problem, but typically like the SAC 305 profiles are all very similar. This is one with the thermally stable flux. This is one that's the normal, refrigerator needed flux. They're both pretty much the same because they're both the same formulation of lead. Now, this gives you your total time, so you can view here, and this is how you get your total time of your flow. Now, the solder wants to be heated, and what this is your initial warm up here, and then this is the soak time, and you want to soak it here, and this is where you're warming up the PCB to get ready for the the advanced more heating. But during this time, you want to keep it low enough to not really burn off the flux, but hot enough to warm the board up. So you want to follow this curve pretty well. And then when you get here, you want to spike up a bit. And then in your last zone, you really want to spike it right at the end. And then you want it to drop off as fast as you possibly can. That's usually dealt with fans and such. Mine is a conveyor oven, so it's a bit different than some of the other ovens that people use, but this is all pretty similar. Basically, you just need to know your times here and take a stopwatch, or I forgot, that's another thing you may need, is a stopwatch or a cell phone to measure your time. Now, you want to take readings at every one of these points, and when you take your reading, then after this is done, you want to take the board out and cool it completely, 100% back to room temperature. Otherwise, you won't get an accurate reading, and it also will burn the board up. You can keep reusing them a few times if you actually cool it down. This is an example of how I've, made my plots before, and basically you run it through, and if it doesn't hit your marks, then you adjust the temperatures in the different zones or in the different timings. Mine has zones. It has 3 zones with top and bottom heaters, so there's actually 6 adjustments. I'll get to that in a minute. But this is basically an idea of what you're looking for. So basically, you just start out there. You measure your temperature, you measure your time, and you take marks on every one of them. And if they're not hitting those times and temperatures, you need to make adjustments in order to make that happen. This, there's different results that happen. If you get this too hot, you burn off your flux too early. It is visible in your final product. You'll get some things that are cold or not reflowed properly. Same with the ramp ups. If you don't get the ramp ups right, you can either burn your board or not heat it enough and it won't flow. Also with this, you need to hit your max, but you don't want to go much above that. Next consideration to take in is you want to go through your entire data sheet and verify that none of your parts can not exceed these temperatures. Some parts, it's directly listed in the data sheet that you can't exceed a certain temperature for a certain length of time. That's another thing you're going to need to take into consideration when you're planning all of this. But most of this information, is not super relevant unless you need it to be. If you need it, you'll know. But what you really need is just this chart here. All right, so now I have my PCB prepped here. I have Kapton taped on the thermocouple onto the board here, and I placed it on the BGA area. Now, You know, with some of the profilers that you can buy out there, they have like 8 leads and you can connect them all sorts of various points, and you're actually, you know, some people say put the chips on there and stick the things underneath them. Some people, you know, even drill out the boards and use epoxy to embed the thermocouples. There is a special solder that you can solder the thermocouple directly onto certain points if you want. I don't have any of that, or if I do, I'm not going to use it, but basically just taping it down seems to work for me. Now, this isn't totally 100% exact because, you know, in the real world situation, there's going to be a lot more components on here, and this ball grid array is going to have a chip on top of it, which, you know, is going to affect the temperatures and everything else. So take that into consideration. But in my world, everything on this board I can hand solder except for this BGA. So this, to me, is the most important temperature to hit. Okay, so that's on there. And like I said, there's different ways to do this. You just want to make sure it's secure. Mine's a conveyor oven, so I actually have the cable coming out the other way. It does seem to make a difference which way you feed the boards in at times. Like this is a rather heavy board on this side, but kind of light on this side. So you would think feeding it in this way first might be better because it's lighter, but it seems to be that if you feed the heavier side in first, it kind of soaks the board a bit better before it actually gets to this point and it flows more proper instead of having kind of a surge. It's hard to explain. The biggest issue areas on this board are right here, this inductor and these pieces, because this is a very heavy area, power supply, you know, stuff, and these are the heaviest parts, and they're all kind of in a cluster. There's, you know, 3 big caps and then a big inductor. So that's the area that doesn't flow well, but you can actually visually see that and make adjustments as you go with my oven. I'm not 100% sure which oven you're using, you know, or, you know, if the little ovens even have windows on them. But we'll see more of that here when we get going. All right, the oven I'm using today is a Mancorp conveyor oven. It's actually rebranded as Semtech oven, which, you know, was used. I got it used. So it's a 3-zone, has conveyors. The belt broke, so I actually don't use the conveyor speed off of here. I hacked on some stepper drivers and I have external control, but all that's basically the same. Internally, you've got, you know, upper heaters, lower heaters, 3 zones, so first, second, third. So that, you know, when you're setting up your profile, those are the areas you're thinking of. This is your preheat, soak, this is your other, you know, ramping up, and then this is your final heat, you know, your final zone, which is actually the flow zone. So those are the areas you need to know about. When I use this thing, I put some little sheets underneath there, underneath my boards, which are actually just Walmart bake mats. They work pretty well. For this, with this oven, the way it is, I'm using double-sided boards. I don't like the parts dragging on the bottom here. You know, these are basically springs. They're not like cables like you'd think. So this kind of helps keep the board moving and it doesn't get stopped on stuff. And also it evens out the heat a bit because these are copper mesh. So I've got my PCB here, and it's ready, and I have it plugged into the thermocouple port on the side of the machine. Now, normally you want to first remember, the first thing you want to get when you get going here is your ambient temperature. Now I'm kicking the oven on. It's not actually heating, it's just powered up. So you can see here on the front has 6 zones, it says, but it's really 3 zones. Now you got your probe. Probe says 17C. So that's one thing you need to know. That's my ambient temperature right now. It's a little cold in here. It's a little below room temperature. When you set up your profile, you're going to want to know that temperature because everything is going to be relevant to that. Everything will be off if your ambient's off, assuming you have an oven similar to this. I mean, it kind of affects everything, but you want to know about that because that is your starting point when you put the boards in. You can sometimes preheat if things are too cold, but you also want to know that temperature as well. So you start with your ambient, and then you basically, when you set up your 3 zones initially, you want to, the best way to do this is, I have the book for my oven, and it gives you some basic generic recipes that are for the board dimensions and how many parts they have on them. It doesn't really compensate for the heavy boards we're using here. I mean, this is 4 layers of 1 ounce. It's fairly heavy. So that plus the amount of parts, there's compensation needed. So the real world adjustments are best to be done with the thermocouple. Now, I start with a generic profile, and then from there, I'll run the board through a couple of times and get it kind of close. Now, I've done this before in the past plenty of times, and I end up just storing them in my machine here, and then from there I just reuse them, but I have moved around a bit, and the temperatures in my ambient and the shop are a bit different. Now, I also have a hood vent here, which, you know, pulls in or pulls air out to the outside. It actually has a big inline fan up in the wall, but so when I do set this up, I will have to have that hood vent on for ambient considerations, but you know, I have it off at the moment for recording's sake. But keep that in mind. You know, all your vents should be on when you're doing this. All your normal operating stuff should be happening while you're doing this and while you're setting up your initial profile. Alright, so now that we have the board known and the solder paste known, we go to our guide here in the manual, and this one happens to have some presets in it. There's also some presets built into memory here, which come by default, but it's always good to check the book as a starting point. Now, my PCB is about 110 by 110. It's 4 layers of 1 ounce copper, so, and it does have a lot of parts on it, you know, on the top. So the bottom doesn't necessarily, but it's still a heavy board. So let's see here. So the range we're looking at is somewhere in this area. PCB thickness 1.2, 10,000 to 15,000 millimeters squared. So average, dense, or with PLCCs. Now this gives you all your settings there. Now what those numbers are is preheat, soak, reflow, conveyor speed, and component density. Now conveyor speed should probably be set based off of the solder length of flow time, not off of, you know, an estimated heat time. So I would actually set the conveyor speed, and that's what I do, based on the length of time the solder expects it to be through the entire phase. So then you go here, you get your starting point, 215, 175, 125, 130, 330, you know, and those numbers. So I have one that is close, that I'm just going to start with, that looks very, it might be a little high on some of the things there, but knowing this board and the way things are, this is probably a good starting point, even though the book says a bit lower, but not by much, just in the flow phase. So we can test this and see where this goes. Alright, now to set the conveyor speed. So the solder paste profile here, you know, it's largely an estimate. I mean, it's close, but so basically about 300 seconds you want it to be, you know, all the way through the phase, past the heater, and on its way to cool down. Now on this machine, you know, you enter here and you exit here, and I measured it and wrote it down. It's 920 millimeters from to this point where it starts hitting the fans. So it's basically heated all the way till that point. So doing the math, you get about 185 millimeters per second. Now, even if, so this thing's been modified, I, you know, put these motors on, and so I have to adjust it differently. But if you set your conveyor speed, even if you are setting manually through here, it's good to check it anyways, because, you know, this machine particularly is a PWM driven motor. You know, there was a belt initially and a whole bunch of other things, so there was ways that it could get very far off. So you want to check that this is actually a real speed anyways. Now, how to do that is I just use a stopwatch, take something, anything, set it on there. There's the time it went in, and then you just time it until it comes out, divide, do the math, and that gives you your total feed per second or per minute or whatever you need. So to get those numbers, that's how you do it. Alright, now that I've got everything all warmed up and running, I'm going to feed this board through. Now I'm going to start my stopwatch once it actually gets into the oven, and then time it all the way through, and the whole while making notes on the temperatures at the set times that are listed here on the data sheet. So after I'm done with that, I'll give you more of an update. Alright, ran the board through, got it cooling down now, waiting for another pass through. You want to get it back to room temperature before you run it through the oven again. You can see it's at 39, 37. It's cooling pretty quick because I'm, you know, using the fan on the top here. Now, the results I got were this. As you can see, I was a bit low of the points on every case, so you can see my chart there after running it through and testing at those times just using a stopwatch. You can see how close I can get to the curve and where I need to adjust at. Looks like I need to increase heat on the first zone, probably upper and lower. Second zone, same thing, you know, third also. So that gives you an idea of basically how you do this. And you just go through and keep running it and keep plotting and, you know, do the over under. You can do things like increase your temperature of your, you know, soak time to help compensate to increase your preheat time here, or your ramp time, but you also have to take into consideration burning off your flux. So that's the area where you want to warm it up but not hit your flux temperature. This is where you want the flux to start cooking, and that's where you want the flux to burn off and the solder to flow at the same time. And then you want as quick as you can of a drop back down to cold again after you're done. So it gives you an idea of what you have to do and the process. Alright, so now after running it through again with one of my known profiles that works, which is these temperatures, is what I ended on. You can see the middle one there is my last plot, and you can see I'm pretty close to what it's supposed to be. So now I feel confident that it's no problem to just, you know, start throwing boards in. So I have a bunch prepped here already. Alright, now that I have that profile done, I feel confident running boards. Now this machine, I can kind of just feed them in like this. You just have to give a reasonable space, but you can usually have 5 or 6 in the oven at the same time, which is nice. Typically there's one coming, if you can get the cycle right, you can always have one coming out as one is going in. And, you know, it makes for a good hour or so when you run about 100 boards. It's not so bad. It's 5 minutes a cycle, but then again, if you're doing 5 boards in a cycle, you're really only doing 5 boards in about 6 minutes, so that divides out to about a minute and a minute and something per board, minute 15 seconds per board, minute 12. But that's not bad, you know. So that's the benefit of the conveyor versus a normal oven, like as in a typical, you know, enclosed oven. There's also vapor phase and those other ones that are really nice, which I would love to get into, but currently this is what I'm using.